Thank you for joining the Resilient Cyber Show. My name is Chris Hughes, and today we're joined by Magno Logan. Magno, thanks for being on.
Yeah. Hello, Chris. Thanks for having me. Yeah.
Yeah, absolutely. We're excited to chat with you. So, folks, that don't know you, haven't seen your YouTube talks or any talks at conferences you've done and things like that. Can you tell us a bit about yourself and your background?
Sure. Sounds good. So yeah, my name is Magno. I've been in security for over 10 years now. My background is as a developer. I've done a lot of everything around application security, pen testing, secure coding. And lately I've done some research around cloud and containers. And I believe that's what we're going to talk about today.
Yeah, definitely. That's how I came across you. I've seen a lot of your content around Kubernetes and containers and things like that. And I was like, wow, he really knows what he's talking about. He's got some great information, great content. So I'd love to chat with him. So for folks that don't know, what containers or Kubernetes are, do you mind, giving us kind of a 101? What are containers? What is Kubernetes? Why is this relevant?
Sure. Sounds good. So yeah, basically containers were created even before Docker, right? Most people know containers from Docker, but it was even before that. And it was a way to run processes in an isolated way. Today, containers have become much more. It's like a lightweight package of your application code and all the dependencies, right, with specific versions and libraries. And everything that's required to run your application is packaged in one single image or container, right? And basically, when you have that and you have kind of multiple containers, that becomes hard to manage, right? So you need something to manage maybe hundreds or thousands of containers depending on your application today. And that's where usually Kubernetes comes in. Kubernetes is a container orchestrator or container manager, right? So it helps you manage the hundreds of containers that you may have. It helps keep them stable, healthy, alive, helps with updates and rollbacks. So Kubernetes was created like 1 year after Docker launched, but in a way to help manage different containers, right? There's other container managers out there, but clearly Kubernetes is kind of taking the lead there on the container orchestration part.
Yeah, no doubt about it. It's definitely become like the container orchestration tool of choice. And when you look at the industry and where everyone's going, and what people are adopting and using, it's no argument there. So when it comes to containers, you talk about being lightweight, portable, repeatable, those kind of things, immutable. What's leading organizations to like increasingly adopt containers and move away from virtual machines? To the kind of next compute abstraction. For lack
Mhm.
of a better term.
Sure. Yeah, what drives organizations is mostly profit, right? Either increasing profit or reducing costs. So with containers, you have that, like it brings that technology because first, it's cheaper. It's usually cheaper than a VM, like to run and deploy that container. It's faster to run. You don't need to install an operating system and have another kernel there to your VMs to basically to run your containers. If you have a host or a managed Kubernetes or container service, you can do that right away. So I think those are kind of the business kind of adoption, the reasons for adoption, but also for technologies and developers and IT folks. Basically, the first problem that you face if you were a developer 10 years ago, the first problem that you solve with containers is the dependencies, right? Different libraries with different versions, and if you try to run applications that require the same library but with different versions on the same machine, then you're going to have problems, right? So you need either like a virtual environment or containers to help you with that. Um, and I think the kind of the concept of immutable infrastructure that comes with DevOps, right? The approach of not patching your systems, like going and SSHing to a server and updating your packages, but rather than doing that, deploying a new version of the server or the application that has all the fixed versions and fixed libraries. I think that's what brings the container adoption, Kubernetes adoption, like increased a lot over the years.
Yeah, I definitely don't disagree there. A lot of folks will cite, the benefits of, moving things towards a DevOps workflow, managing infrastructure, as code, having immutable infrastructure so you're not changing things in place, having configuration drift, moving towards more of a GitOps type deployment model. Those are all things that commonly are cited for sure. So, kind of pulling the thread on that and keeping that thought going, when you think about cybersecurity and you're starting to move to containers, you're starting to move to Kubernetes, what are some of the fundamental things that start to change that are a little bit different, when it comes to securing containers and Kubernetes and, maybe say a virtual machine, for example?
Sure. So if you have the baseline, right, if you understand networking and Linux and all that stuff, like that helps. But there is an added layer of components that containers and Kubernetes bring that you need to understand as well, right? So just talking about Kubernetes, when you have the control plane and worker nodes, and then you have kubelet and kube proxy and all those little components there, you need to understand how they work and how they communicate. So understanding the Kubernetes architecture there. For example, just in Kubernetes alone, there is 3 APIs at least that are kind of exposed either internally or externally, right? So you have the Kube API server, which is the main one. Then you have the etcd API, and then you have the kubelet API, which usually internal, but can be compromised as well, can be attacked from an internal perspective, right? So all those little things and little pieces and can add this extra complexity. And like I struggled in the beginning with Kubernetes when I was learning. It's like, oh my God, this is too complex. Like I can't understand this. Like, am I dumb? Like I don't. I asked this question because it was very complex in the beginning, and like to understand those little pieces, it takes time. So for anyone like in cybersecurity, that anyone that wants to understand Kubernetes security, I highly recommend that you first understand how Kubernetes works first, then go into the security part.
Yeah, I definitely agree there. And, to your comment of it being complex, I work with Kubernetes, programs that are using Kubernetes, I should say, like on a daily basis. And, I still feel like the more I learn, the more I don't know. It's like, oh, the rabbit hole just keeps going and going.
Exactly.
There's so many moving pieces and parts, and it's very complex, no doubt about it. You talked about a couple components like etcd, for example, and kubelet. For people not familiar with like etcd or kubelet, what exactly do those do within the architecture of Kubernetes?
Sure. Sounds good. So etcd is the database for Kubernetes, right? It's the key value store for storing all your Kubernetes configuration. And basically everything that's stored on etcd is reflected on the cluster, right? So for example, if I want to increase the number of containers of a specific application, I increase that number of replicas, for example, and that gets saved on etcd. And then there is a controller that notices that change and then checks that with the desired state, right? So is the cluster reflecting what exactly is mentioned on etcd? If not, then they're going to make changes. Kubernetes is going to handle that and either deploy more containers or reduce the number of containers that you have to reflect that number, right? So basically, etcd has all your configurations, and it can have sensitive information as well, right? So secrets and other kind of components there that may lead to a compromise for an attacker. The kubelet, it's basically the Kubernetes agent that you have on every node. And when I say every node, it's even the control plane. Although the Kubernetes architecture diagram doesn't show that, if you go to the official website, at least last time I checked, it doesn't show a kubelet on the control plane. And that gets confusing sometimes. It's like, how does Kubernetes deploys pods inside the control plane? Because it needs those management components as pods and needs to deploy that. But basically, the kubelet is the agent of Kubernetes, right? It runs on every node, and it helps your deploying containers, keeping your pods healthy, and also sending information back to the Kube API server.
Yeah, I think what you're hitting on is leading to some of the comments you made earlier about like drift detection, the immutable infrastructure, and you have that reconciliation loop. So if you have a drift, right, it's being corrected, so you don't have kind of like infrastructure configuration sprawl. It's in the state that you've declared it to be, and it's going to be reconciled as such. So that's kind of the power of this new paradigm of operating infrastructure. So another thing I wanted to ask you, when organizations look to adopt Kubernetes, it's very complex, even for people who work with it, on a daily basis, for sure, no doubt about it. People are often faced with the decision of like, should we, roll our own, as they call it, manage our own Kubernetes, for example, from scratch, from the ground up, or should we look to use maybe a managed Kubernetes offering from a cloud service provider, something like AWS EKS, for example? Any thoughts on like how to approach that topic and, which way to go, that kind of thing?
Sure. Yeah, if you're looking to learn Kubernetes, then definitely deploying the unmanaged service, right, on your own, and kind of creating your nodes and syncing the control plane with the worker nodes for learning. That's a great approach. That's great to understand the concepts and all the components. But for running in a production system, unless you have like a specific security or compliance requirement, I would definitely recommend use the managed services, right? First, because it helps with some of the security defaults, and second, because like you don't need to handle the control plane, right? Usually those managed services, they handle the control plane for you, and all you need to take care of are your worker nodes and your applications. So that simplifies things a little bit, and it kind of, especially for smaller organizations that are trying to leverage Kubernetes for scaling, right? So that helps a lot.
Yeah, I think when you're talking about control plane, you can kind of infer like this may be important, right? It's managing all of my workloads, all my workloads running within my environment in production. Maybe we might want to let someone else do this if we don't have the resources, the requirements to do it ourselves. So on that note, you talked about the API and being publicly exposed in some cases. I read a study recently where some researchers identified over 380,000 publicly exposed Kubernetes API servers. And that can be alarming when you're talking about being publicly exposed, being able to access over the internet, malicious attackers being able to maybe get into your environment and compromise your workloads. What's leading to that such of a high number of publicly exposed Kubernetes APIs, and how do we get away from that kind of thing?
Okay, sounds good. Yeah, there has been some articles around that topic lately. I've seen that too. I just think that sometimes some of these articles can be a little bit of FUD, right? Fear, uncertainty, and doubt, or trying to kind of increase the problem than it really is. Because, like, what does expose really means? It's like, okay, yeah, you found the web server with the port open, that's exposed. Like that any website now is exposed. Then, like, okay, any website that's publicly available is exposed. Or what? It's just that API server was responding to a request, but did they get access to the cluster? Was it like unauthenticated, right? So that can be very tricky, because if you're looking the wording there, that sometimes it's used for those articles, it's like exposed, it means like compromised, vulnerable, and it's not like that, right? It's just because the API server is exposed, and the main reason for that, it's because the managed services for Kubernetes usually have this default setting. When you create a cluster, either on EKS, AKS, GKE, for example, or any other, right? The Kubernetes API server URL, which is kind of usually a very long URL and hard to guess, but basically that's what it's exposed. But if you don't have, technically, if you don't have authentication there, if you have like just the anonymous access, as we call in Kubernetes, then you might not be able to do much, right? You might just be able to get the Kubernetes version and the Go version that it's using, or like the managed service version, but that's it. Like, of course, yeah, that's not a good, like, I'm not saying that that's safe, but it's like sometimes people try to like extrapolate the problem, like then it really is, right? So I published an article recently where I talk about the kubelets being exposed. So the kubelets have an API, as I mentioned earlier, and the kubelets being exposed, then without authentication, that can reveal information about the containers, the pods that are running, images and other sensitive information. That's a bit more, I would say, like unsafe or tricky to handle, right? But just the API server being exposed, it for me, it's not a big deal.
Yeah, I agree. I agree with you there. I think there's a little bit of clickbait, headlines, high numbers, exposed, certain terms to like, spark some fear in the community, no doubt about it.
Mm-hmm.
And it can be scaring, scary, I should say. But that said, like as you said, Kubernetes is very complex, and there are a lot of opportunities for misconfigurations. I've seen some great reports from groups like Palo Alto's Unit 42 Threat Research Group, for example. If you're using, like, say you go out and you're using a Kubernetes manifest that you found online, or a container, a script, or, infrastructure as code manifest that you just take and start to use on a public repository, there can be some, misconfigurations or vulnerable configurations, things like that. For organizations getting started and trying to reuse maybe some things from other places, anything to watch out for, or, how to ensure if you leverage something from someone else that it is secure, it is configured appropriately.
Sure. I think everything starts from on the developer side, right? When developers are leveraging Kubernetes and writing Kubernetes applications. So everything from a security perspective can start from the Kubernetes, the kubectl plugins, right? So there is a kubectl crew, which is like a repository for kubectl plugins. Kubectl is the CLI for handling Kubernetes, right? Basically, so just like the Docker CLI. But then you're downloading plugins off the internet, of someone else's GitHub, and that's not like vetted or any, doesn't go through any kind of security process, right? Security scanning or anything like that. So it starts there. So there is a lot of kind of points during your development lifecycle for a Kubernetes application that can be compromised, or can leverage, can be like can happen a supply chain attack, right? So that's usually like the plugins, the images that you're downloading that from Docker, for example. Those manifests, they might be okay to use, have sensitive, kind of overly permissive service accounts, stuff like that. I think that was the latest report from Unit 42. They did a great research on some components that have containerscape and kind of compromising the cluster. So just, you need to be aware of those components, right? And you can't trust anything off the internet. So that's true.
Yeah, that internet will get you every time. It's a dangerous place. So I wanted to ask you too, like when you're looking at, obviously it's like a double-edged sword. These are reusable components. You can go out there and get these things on the internet and reuse them in your organization. There's a lot of value in that regard. But like, is there anything we could be leveraging, like, say like a CIS benchmark, a DISA STIG, things like that, to have like a hardened baseline of how we're implementing these, new infrastructure constructs?
Sure. So yeah, there is a CIS benchmark for Kubernetes for a while now, and there is specific ones for managed services, I believe, the EKS and AKS as well. So that gets updated very like often. That's great. You can leverage the Kubernetes benchmark, the KubeBench tool, to evaluate your Kubernetes clusters to see if they are aligned with those benchmarks. There's also a hardening guide from the NSA or CISA as well that they publish and updated recently as well to reflect the latest versions of Kubernetes and cover some good topics there. But from like an operational perspective, I really think, like, I like the approach of the what I call the Kubernetes trifecta. So at least having those three tools, it's like the minimum that you should have when dealing with Kubernetes. So an image scanning solution, right? So it can be to scan your container images for vulnerabilities or anything like that. The admission controller, right? So either something like the pod policies or the pod security policies, which there is a new version now, or leveraging third-party tools such as OPA or Kyverno. So the admission controller there to control what goes inside your cluster, right? So you can create policies for that. And then the runtime security, right? Making sure that, okay, after your containers are running, have they been compromised? Are there any suspicious activity going on? Is anyone installing new packages or trying to install curl or wget or whatever there? Like that seems suspicious, right? So those three, I think, are kind of the baseline for a good Kubernetes security approach.
Yeah, you kind of got to, what I've looked and leveraged quite a bit is like guidance from CNCF and the Cloud Native Security Best Practices white paper and software supply chain white paper. When you think about whether you're talking like in a registry or in a build process or in a runtime environment, like understanding that life cycle and the different areas of being vulnerable throughout that life cycle is kind of how I've approached it too. I wanted to ask you something you just touched on, and it came in a question from the audience actually right now too.
Sure.
Any comments or thoughts around like security context, OPA, Caverno, those kind of things?
I think the admission controller approach is great. It helps kind of eliminate a few things and protect your cluster from vulnerable containers or containers being downloaded from used by kind of unknown registry or public registry, for example. But you need the right policies, right? So if those tools don't offer good default policies, right? So if you need to write your own, so then you need to understand how those policies are written and have resources to kind of understand those and create new policies, right? So that can be tricky. But also, I like to kind of do the analogy of the admission controller is like the bouncer of a nightclub, right? He's there just okay. Oh yeah, you can get in, you can't get in, and stuff like that. But then after you get in, forgets about you, right? So there might be situations be bypassed as well, where okay, yeah, the container seems kind of non-malicious, seems okay, and then after the container is running in the cluster, that's when it starts doing some malicious things. So that's why the runtime security is also important there, right? Because if you have one and not the other, then there can be some bypasses.
Yeah, you're getting to the quintessential, kind of always present within cybersecurity defense in depth, right? Like
Exactly.
one thing is not enough. You need to be thinking about the entire life cycle and what can go wrong. So one thing I want to ask you too, while we have you here for a little bit longer, is when you talk about like software supply chain security, this is a topic I've been focusing on a lot, and working on a book and just reading a lot on lately. How do you think software supply chain security plays in when we're talking Kubernetes containers? You're talking public registries, build pipelines, things of that nature. How does software supply chain play in the context here, and any things to watch out for?
Sure. Yeah, definitely. Supply chain is a big deal with Kubernetes and any kind of software developed pipeline, right? But you have to look for the problem from the start. Where does it start? It starts usually on a developer machine that's writing code and then publishing that to a repo and then generating that image, publishing that image to a registry, and so on and so forth, right? So you need to have some verifications, at least kind of some even smaller ones, some checksums, some hash comparisons, whatever it is, every step of the way, right? To ensure that, okay, what's being done in the previous step, it's actually what I received on the next step. And then I'm leveraging that artifact or binary or image on the next one, right? So kind of some validations and some checks, either signing your containers, either validating those, whatever you're trying to use. Like there's a lot of great work being done with the open source project called SigStore, right? So there is some help there. But it's like you have to think every step of the way, because if any of those steps can be tampered with, can be manipulated, then your whole pipeline can be compromised, right?
Yeah, you actually, I was going to ask you about SigStore, so I'm glad you touched on that and the signing concept too. Bringing some rigor of integrity, right, to the process. Another plug is like if you look at Salsa, the framework that's been put out there for software supply chains. Another great thing in terms of how it can go through the build pipeline and process, throughout the life cycle. So yeah, definitely for sure. So one other question I had for you is like, obviously Kubernetes is a very daunting concept. If you've never worked with it before, you're not familiar with it. Any learning resources that are kind of a favorite for you, or go-to learning platforms, or just books or anything like that you want to recommend to the audience as well?
Sure. I'm a bit biased here because I have my own GitHub repository of Kubernetes stuff. But basically, when I started Audi 2 years ago, right, 2020, when I started kind of doing a lot of research around Kubernetes and understanding their concepts, everything was scattered around the internet, and like, okay, yeah, this blog post is interesting, this information is interesting. So I started gathering all that information in one single file. It was basically a test file on my computer, but then I decided to share that to the community, right? So then I created this awesome Kubernetes security list on GitHub. So if you go to the GitHub, my repository is there at github.com/Magno Logan. There is the awesome Kubernetes security list, and there are many links there available for regarding articles and books and videos, talks, and everything there from you to start Kubernetes and then to do more kind of security research, right? So you need to understand Kubernetes to be able to do Kubernetes security. So just two books that are very important and I think are highly recommended. The first one is Container Security by Liz Rice. It gives you a very a basic understanding of Kubernetes, about containers and kind of security and all the attack surface and everything like that. It's a great book and it's a short one, a very short read. And there is a new one by Andrew Martin and Michael Hausenblas that's called Hacking Kubernetes, right? And so I had the opportunity to be one of the reviewers for the book, catch the early release, and it's a great book, highly recommended.
Yeah, it's so funny you mentioned those. I have both of them on my bookshelf right here. I read Container Security like early on from Liz Rice. She's incredible, kind of a pioneer in this field. And then the Hacking Kubernetes, I've read it twice in the past 2 months, and I've shared it like at least 3 or 4 times on LinkedIn. It's an incredible book. It kind of goes through the whole spectrum of like threat modeling Kubernetes. Everything from supply chain security to runtime security. Like every aspect of it. It's such an awesome book. I definitely recommend it for folks. So the last question I have for you that we ask everyone that comes on the show, is what does the term cyber resiliency mean to you?
Cyber resiliency. Okay. That's interesting because I used to practice martial arts, and one of the concepts that we discuss in martial arts is kind of resilience, right? So resilience means basically the ability of something or system, in this case in cyber, right, getting affected or changed by any reason, but being able to return to its original state, right? So resisting changes or attacks or something like that. So I believe that cyber resilience in this aspect is basically creating systems and applications that are able to withstand some changes and attacks and kind of going through that, right? You're never going to achieve 100% security, but having that minimum required protections to be able to navigate, right? Having those guardrails to navigate that space and make sure that your application is still inside those guardrails. So I believe that would be my definition of cyber resilience.
Yeah, I like that. I actually just got back from jiu-jitsu earlier this morning, so I can definitely relate to.
Awesome.
I had to have some resiliency in there this morning. So I like the answer. Well, that said, thanks so much for coming on, Magno. And for folks that want to find more about you and that kind of thing, are you active? It looks like you're active on Twitter. I see a Twitter tag right there. Sounds like Twitter and LinkedIn would be the best place to find you, most likely.
Exactly. Yeah. Most of my social networks are Magno Logan all together. So either LinkedIn and Twitter are the ones that I check the most often, but some GitHub or stuff like that. I'm always available to chat and ask questions, answer questions, and help people with their journey. So happy to be here, and thanks for having me.
Absolutely. Thanks for coming on. Thanks for everyone tuning in. Take care.